This morning, it's my pleasure to introduce Dr. Keoki Jackson. He's the Chief Technology Officer at Lockheed Martin, where he's responsible for the corporation's advanced technology strategy. Dr. Jackson has also worked as a NASA Research Fellow at the Massachusetts Institute of Technology, Program Director for Global Positioning Systems at the Lockheed Martin Space Company, and various technical and leadership positions in space-based communications, navigations, and missile warning. Ladies and gentlemen, please give a warm welcome to Dr. Jackson.
Thank you, Colonel Erickson, Colonel Hall, Colonel Tarian. Good morning, everyone. The Hardy Bunch here. Welcome. And thank you all for being here, and thank you for the opportunity to be part of this amazing event. It really is a pleasure to be here, even though this is sort of our first wintry mixed day, if you will, that tends to shut down Washington, D.C. And I want to start off by being clear. I'm not a cyber guy, so just so we have that straight. But I do have the responsibility for setting the strategy and developing our plans for insertion of advanced technologies across Lockheed Martin. And that includes both advanced cybersecurity techniques as well as ensuring that the advanced capabilities we develop are designed ultimately with cybersecurity in mind from the outset. And it's probably no surprise to you that cybersecurity is actually one of the core technology areas, what we call foundational technology threads, at the heart of Lockheed Martin's technology strategy. I also have the responsibility for our information technology organization and systems, so that's roughly 5,000 IT professionals across the organization, including a dedicated core of cybersecurity experts who work closely with our customers and government agencies represented here today to secure the systems and the information that are the lifeblood of the programs and the capabilities we are entrusted to develop for the defense of the U.S. and our allies. So the topic of cyber conflict and competition resonates very strongly with me and my team. It's part of our everyday lives. And to introduce some of the themes I want to cover today, let me start with a little story. So last year, our team conducted a cyber tabletop, an assessment of a DoD weapon system being delivered on a Lockheed Martin contract. We did that with the military customer team and with the NSA. Now, as you'd expect, the tabletop generated a whole series of plausible cyber attacks, some of which would have serious impacts on the mission. And that's all good. But more interestingly, the event showed the combined contractor and customer team that our assumptions prior to the event about the most serious class of cyber threats were actually wrong. Another class of threats that the team assumed initially would present only a small attack surface, turned out to pose the most serious threat. The Lockheed Martin and the customer team agreed that we needed to completely change the cybersecurity implementation for the next program delivery to address those most critical threats. And afterwards, I quote the customer here, these CTTs, the tabletop exercises, are critical to identifying design vulnerabilities and understanding the asymmetric nature of the cyber threats. There is no substitute for these type of events. But what did this experience teach us more broadly? I mean, first of all, this is a team sport. The combination of developers, of system operators, and external cybersecurity experts found things that no single individual or group would catch. So it really is the winning combination of knowing the architecture and the design, understanding the mission environment and the operational concepts, and ultimately the awareness of the latest threats that makes the difference. And we also need a holistic look. These sophisticated network systems are comprised of subsystems and products and components, both hardware and software, delivered by a very complex network of partners and suppliers. Next, the nature of the threat is always changing, even for a system that may have been operational for many years. And that brings me to a related point. Cyber protection starts with the steps that lead up to delivering uncompromised. But the cyber mission never ends as long as these systems are in service. And that all means that we have to develop both a shared focus on cybersecurity over the complete system lifecycle and contractual mechanisms to plan, to fund, to execute this critical element of any program that extends through the whole trajectory of operations, maintenance, and sustainment. So this might seem like common sense, but it's enlightening as we think about the modernization challenge ahead of all of us. So I'd like to talk about what we see from our vantage point in the aerospace and defense industry, what's working well, what needs more work across our community. So given our audience, I thought I'd start in the context of the Army's top modernization priorities. But it's safe to say that the conclusions hold if you were to take a similar look or a similar chart with the focus areas for any branch of our military services. In fact, I'll summarize the future of warfare in a few words here. Faster, more connected, more non-kinetic, and more autonomous. Did I say faster? So let's take a look. Systems like long-range precision fires or better defense against missiles and drones are only effective with fused sensing, rapid targeting decisions, and systems that can match heterogeneous weapons against swarms of attackers, then fire and assess the results. For future vertical lift aircraft or next-generation combat vehicles, these future platforms will be lethal and survivable, they'll be super mobile, but they're going to have advanced human-machine interfaces that allow them to be optionally, or maybe more to the point, optimally crewed. In the case of future helicopters, think selectable autonomy to support 2 pilots, 1 pilot, no pilot at all, depending on the nature of the mission. Soldier lethality will rely on distributed wearable sensors, body armor, smart load-bearing exoskeletons. But these are going to provide timely information, they're going to assist in decisions, they're going to react to the environment and to the soldier's state and the soldier's workload. So this is a suite of information-enabled technologies to enhance human performance on the battlefield. And bringing this all together will be new communication networks that operate seamlessly in the spectral chaos of a heavy jamming and electronic warfare environment. So the obvious implication is that a robust modernization for the Army depends completely on information. Autonomy, sensor integration, decision aids, weapons deployment, and resilient communications networks that tie it all together. And by extension, protection of the information and networks with robust cybersecurity is not an option, it's a must-have, delivering critical data where and when it's needed, uncompromised. So that backdrop illuminates where we need to go, but what's the environment we're seeing in the defense industrial base? The statistics are certainly grim and the costs are staggering. The scale and the scope of the threats sometimes is hard to imagine. And I just look at things like 250,000 new malware samples each day. And that's according to Symantec's latest Internet Security Threat Report. Tens of thousands of malicious mobile apps blocked daily. Attack sophistication that continues to increase from new approaches to stealing credentials to using advanced encryption to camouflage nefarious intent. Moreover, all of our industries are in the midst of transforming digitally, touching everything from design and manufacturing to supply chains, logistics, and sustainment. The mushrooming attacks in areas like the Internet of Things devices, that increased over 600% just in 2016 to 2017, highlight the new vulnerabilities that connected enterprises confront. Now, while most of these numbers actually refer to consumer-grade type devices, personal cameras, home routers, things like that, the message is pretty clear. Our corporations need to apply focus to the issue of industrial IoT attacks as we strive hard to capture the benefits for cost, schedule, and performance that digital integration offers. So behind all of this, Lockheed Martin tracks 65 different nation-state groups and advanced persistent threats that have focused cyber attacks on our company over the past decade. We fully expect that in a future asymmetric conflict, defense manufacturers will also find themselves on the front lines as adversaries seek to disrupt our operations. So take a look at the graphic on the right, and it's illuminating. This highlights the shifting trend in attacks that we've observed over the past several years. You see they initially focused heavily on the large defense prime contractors. But consider that on the order of 2/3 of the value of any Lockheed Martin delivered product or system comes from within our supply chain. That's over 16,000 suppliers in 54 countries, and 52% of those are small businesses. So over time, the focus of our adversaries has shifted dramatically, and now the percentage of attacks on the defense supply chain greatly predominates. So the danger for compromise for important information is obviously bad enough, but consider other statistics that indicate that 43% of cyber attacks are aimed at small businesses, and up to 60% of small companies go out of business within 6 months of an attack. So this is an existential threat to something like 8,000 of our small suppliers that in turn are foundational to our industry. So before leaving this chart, I'm just going to note one more thing, and you see sort of in the middle there, the prediction on the number of unfilled cybersecurity jobs in the U.S. from about 1 million a couple of years ago to over 3 million in 3 years. And I'll come back to that in a few minutes. So given this daunting landscape, what will we do? And what will we do together? I think it's important to emphasize some things that are going quite well. And, starting with things like the Cyber Tabletop partnership that I noted up front. The U.S. government's commitment to supporting the enduring security framework and the Defense Industrial-Based Cybersecurity Program have been vital to success. This is a great practice. It needs continuing support at the highest levels of government, as Deputy Defense Secretary Pat Shanahan recently highlighted. Next, the defense industrial-based companies have had a very positive relationship with the U.S. government, sharing threat information since 2008 via the Defense Cybercrime Center. This threat information sharing continues, and in fact increases through collaborative efforts that are also focused on long-term hardening of the supply chain and platforms. And the DoD Deliver Uncompromised initiative should be commended. Industry and government must work together, collaborating to make these courses of action a reality. But there is more to be done, and I'll highlight 3 opportunities. First, we recognize, and I kind of gave the statistics there, on the criticality of securing our supply chains. That large proportion of small businesses lacks the depth and sophistication, but more importantly, the level of financial resources, the cost of entry, if you will, to develop or buy the necessary capabilities for protection. It's clear they need the help of DoD and the large primes. But it's much more than that. Oops. We and our peers need to do things like we're doing with the Cybersecurity Maturity Model Questionnaire developed by the ExoStar partners to provide a cybersecurity maturity rating that triggers additional support for cybersecurity capability improvements. Second, the foundation of trust established by current information sharing practices with the government needs to move to the next level. At Lockheed Martin, we leverage our intelligence-driven defense model to understand when and why adversaries may attack and what they might do next. For example, it should be little surprise that as tensions built between North Korea and the U.S. in 2017, we saw a considerable surge in reconnaissance and malware related to the THAAD program. But as the recent GAO report noted, the high level of classification for weapons systems, cyber vulnerabilities, and threats certainly helps to protect sensitive information, but it makes it difficult for DoD to share information about aspects of weapons system cybersecurity. And this concern is well recognized, as Sue Gordon recently remarked. We'll be pressed to offer that understanding not just to the IC, the policymakers, the warfighters, but increasingly to the private sector, because the threat surfaces of the nation extend well beyond the bounds of government. And third, at the end of the day, solving our biggest cyber problems requires extreme collaboration between the government and industry. To that end, we need industry participation in the cyber task force that was recently stood up by the DoD. This is a fantastic initiative, but it will only realize its true potential with industry engagement. So now, we all recognize that cybersecurity has to be designed in from the beginning. It's too costly, too hard, too challenging to bolt on afterwards. That means applying strong process and standards into the design and testing of all systems, both hardware and software. And incentives should be directed towards rewarding contractors for producing risk-managed systems capable of defending against attack. And I'd note the tax incentives recommended in the Deliver Uncompromised report are one innovative example. But what I'm trying to say on this chart is it's much more than initial development. The government must build cybersecurity requirements into all contracts. This is not something that can be assumed to be included in every new system, and equally, it cannot be assumed to be delivered automatically during operations and maintenance, or even in planned upgrades and capability insertions. Industry and government need to figure out how to cost the continuous evaluation of systems for cybersecurity and build this into budgets across the entire product lifecycle, because the threat doesn't take a break at the end of EMD. This includes everything from funded full-scale cyber penetration testing on a regular basis, to agile methods for continuous integration and capability insertion, to ongoing training to stay ahead of the evolving threats. And that spectrum of needs means shifting our mindset away from called lowest cost approaches to risk-based budgets and plans. So this is transformational in approach at a time when we're all working hard to create a transformation in capability. Lockheed Martin, our partners, have been investing heavily and working hard for years on the technology and the mission priorities that Undersecretary of Defense Dr. Mike Griffin has highlighted for the nation. These include advanced high-speed strike through hypersonics and high-powered laser systems that can create weapons effects at the speed of light. We're working on what we call 5th-gen C4ISR that takes advantage of the full sensing and data integration capabilities of 5th-gen platforms, while developing the communication techniques and cognitive applications that will allow the U.S. to maintain clear advantage in the converging world of the software-defined RF spectrum, where communications, sensing, and EW, and cyber are all merging together. And we're investing in autonomy and artificial intelligence, literally autonomy in all that we do, to create trusted autonomous systems, systems that will be validated and verified, can collaborate seamlessly with human operators, and apply common technologies both for platforms in motion and systems at rest, whether cyber defenses or command and control systems. So bridging across these elements is our vision for multi-domain operations, a secure, composable, open architecture systems approach that's intelligent, distributed, and resilient to permit the speed of decision needed in an environment where we must act simultaneously in air, on sea, in space, on land, and in cyberspace, and where the timelines have collapsed from hours to seconds to nanoseconds in some cases. So one theme is common across all of these information-centric technologies: the promise of speed, survivability, and transformative capability requires a strong foundation of cybersecurity for mission success. So alongside our investments in these technology areas, we have concerted efforts in fields like embedded cybersecurity to ensure that these systems can detect intrusions, defend against them, and reconfigure to operate through attacks to meet their mission objectives, all with very tight constraints on things like size, weight, power, and of course, cost. But the security paradigms that will enable these future capabilities need to change as well. And we've got the future here in the room. In our world, we still kind of operate under security practices, processes, and procedures that have grown up over decades. And they can literally be characterized, in some cases, as vestiges from past centuries. A time dominated by physical security concerns and a mentality of guns, gates, and guards. And don't get me wrong, these are still important. But today's processes are often dominated by compliance and checklist-based approaches and a whole lot of paperwork. and they no longer provide the speed and agility that are required. We're in a world where technologies are changing and evolving at a Moore's Law pace. Cycles of 2 years or less, and new threats can emerge in fractions of a second. So approvals and decision processes that take months, in some cases even years, simply don't work. So this is an area where our partnerships across government and industry can apply modern risk-based methods to make the difference in speed, agility, and resilience. I'll just give an example. We've stood up at Lockheed Martin a cyber resiliency working group that's applying best practices and methods that we've developed under the National Cyber Range program to model threats, validate security architectures, design countermeasures, and trade those measures against other system priorities, then implement them and test their effectiveness in a virtual environment. Importantly, the working group is codifying these methods into our standard systems, our systems engineering, our software engineering processes, while mentoring lead engineers and program managers in the use of these methods and training the broad engineering base. The working group is shifting our engineering culture so that our engineers can effectively bake in cybersecurity and resiliency mechanisms, not just in the systems, but in our day-to-day life. And as a community, we need to embrace that all together. So the threat environment, and a handful of examples you see from places like China, North Korea, Iran, Russia, threat environment is changing fast. And in industry, we're working at maximum speed to develop the capabilities we need to create and maintain truly dominant capabilities for our missions and our customers. To make this happen, we're doing much more than changing what we make. We're actually completely changing how we make it. We're digitally transforming our facilities, our factories, our tool sets, our entire workforces. So cyber protection approaches that are manual and human intensive and do not take advantage of automation, artificial intelligence, those almost guarantee that systems will be out of date and lacking the latest protections. And that's a great disservice to our warfighters. Furthermore, isolation approaches are naive and will ultimately reduce our overall security posture by impacting the speed and the capability offered by modern cloud, software stack, and software factory DevOps approaches. This is an incredibly complex and integrated and interconnected set of systems. They rely heavily on the data that defines our designs, how they'll come together, and how they're operated. And we all know that protecting this data is critical to our security, to our competitive advantage, both as companies and as a nation. But what this sets up, there's a desire, for simple, or in some cases, simplistic solutions. Now, you could say, well, let's take all that critical data, let's put it in one place, we'll air gap that secure system, and we'll know that we're safe. But the reality is we're not talking about a collection of Word documents or PowerPoint. Our CISO likes to make the analogy that data is like the blood in the body of the organism that makes up a modern manufacturing company. It's in product lifecycle management systems that capture requirements, architectures, designs, bills of material. It's in the enterprise resource planning systems that tie our operations, supply chains, and deliverables together around common databases. It's in the manufacturing execution systems that keep our production lines running in real time on the shop floor. So it's not as simple as saying, let's take the sensitive stuff, we'll put it on air gap systems and lock it up. That's like taking the blood out of the body, and then the body dies. So my request to all of you here, who share the same objective of making sure we stay ahead of the threats and don't give our adversaries any advantages. Please work with industry to define risk-based approaches that work with the technology rather than working against it. Let's create our own competitive advantage through continuous development and integration, continuous capability delivery that gives us the speed and the agility to stay several steps ahead of our adversaries. So where do we need to go? This is the future that I envision. First, cyber activities and threats from a wide variety of competitors and threat cyber actors, nation states, mercenaries, criminals, terrorists, influence hackers, and so on, are going to continue to increase. That's a fact, including below the level of warfare across many segments of the U.S. population, economy, critical infrastructure, and defense. But in response, we will continue to mature our defensive capabilities, demonstrate our ability to inflict consequences on adversaries, and take hard measures to protect our vital security information and our intellectual property. In that future, cyber threats are tracked and the information is widely shared to all U.S. government agencies and allies, infrastructure entities, and private industries to identify and thwart attacks before information is lost or compromised, with seamless collaboration and an environment that enables and promotes information sharing. And technologies like AI and big data analytics are heavily leveraged to protect our systems, continually searching for threats, intrusions, and other attempted attacks. We will have invested in and developed capabilities that sense first using AI and machine learning, decide first, in some cases with autonomous support, and if needed, enable our operators to shoot first, to defend against those who would do us harm. Industry will be there ensuring that our warfighters get the best possible capabilities to deter, to fight, to win. And let me wrap up by saying it's not just the stuff, and I talked about a lot of stuff today. It's more importantly the staff that makes us secure. These are the dedicated people that develop the techniques, implement the protocols, keep watch on adversaries and threats, and come up with the creative new approaches to defend and to counterattack. I showed that graphic earlier that projects a gap of 3.5 million unfilled jobs in cybersecurity just about 2 years from now. According to that GAO report, program officials from a majority of programs, so this is talking about the DoD writ large, from a majority of the programs and test organizations we met with, said they have difficulty hiring and retaining people with the right expertise due to issues such as shortage of qualified personnel and private sector competition. This is something we all need to tackle together. I'll tell you, at Lockheed Martin, we know that we have to double our cyber workforce in the next 3 to 5 years. Now, I've had the opportunity in places like Israel to see how that country has made cybersecurity a true national priority, with programs like the Mag Shamim to reach out in high school and start developing students from underserved populations, and incorporating public-private partnerships to enable this outreach, funded by the IDF and educational foundations. I had the opportunity to meet and speak with many dozens of bright, eager young women from outlying communities in a cyber camp in Beersheba, sponsored by Lockheed Martin, the Rashi Foundation. And I saw personally how these kinds of opportunities can be pivotal and life-changing for the participants and open them up to exciting futures and careers in cybersecurity. So how about this? How about a true national initiative here in the U.S. to eliminate that cyber talent gap with concerted national leadership to retain and advance our advantage in this critical field? I know that with focus, partnership, and commitment, it can be done. Last month, my IT team sponsored CyberQuest. This is a capture the flag style event for high school students. I was there with 5 local high school teams at our Security Intelligence Center in Rockville, Maryland. But at the same time, there were dozens of other teams and over 175 students in the event, conducted simultaneously across 4 other Lockheed Martin sites in the US and another one in the UK. I saw firsthand the incredible capability, capacity, and excitement that cyber opportunities draw out of our communities. So I know it can be done. But it's on all of us here to take that experience and multiply it literally thousands of times over. At Lockheed Martin, we look forward to working with all of you to the Army Cyber Institute, to the NATO Center of Excellence, to all of our government, industry, and academic partners to making that difference. Thank you.